And say something for the camera.
Hi kids! Ready to learn about the sand and gravel quarries of Western Washington? Hi kids! You want to learn about the sand and gravel quarries of Western Washington?
No.
Me neither! Puget Sound. There's a lot of gravel and sand in Puget Sound. Puget Sound stretches from Anacortes to Olympia, more or less. It's a fjord, meaning a long, narrow inlet with steep sides, created in a valley carved by glacial activity. It's also part of a larger physiographical structure termed the Puget Trough. That's Puget Trough. That's the, mountains. More mountains. So the last glacial period began about 110,000 years ago, and it ended about 10 to 15,000 years ago, and the glacier was its biggest about 18,000 years ago. It's called the Vashon Glaciation, and it advanced into Washington about 18,000 years ago. Here's a picture that shows the Wisconsin glaciation. As you can clearly see, the ice penetrated into the Puget Sound. Oh, now you can't, let me see if I can zoom in on, there. No. There. You can clearly see the max extent of the Vashon glaciation. Good stuff. This picture's not quite as good, but I think you get the idea. Come on. Here's a short time-lapse video of how the Vashon Glacier advanced and retreated in the Puget Sound. Note that the light blue is fresh water, and the dark blue is salt water. About 4 seconds into the video, if you listen closely, you can hear Al Gore crying as sea levels rise because of CO2 emissions. 20,000 years ago. This slide's not quite right. Hold on a sec. There we go. Where do you find rocks? Basically, you find a rock anywhere. Sand and gravel is abundant from Bellingham to Olympia and North Bend to Little Wap, somewhere out on the Olympia Peninsula. This looks familiar. Here you can see that different sizes require different velocities of water to settle out. Kind of no duh, but still important. Here's a cross-section of the mine and proposed expansion of the mine in DuPont, Washington. So DuPont and Maury Island are two places where there's a lot of sand and gravel. Glacial till in the Puget Sound can often be 100 feet thick and packed in something similar to concrete. The sand and gravel were deposited by the outwash of a glacier. Once the glacier advanced past the deposits, it was sealed by a less permeable glacial till. It is interesting to note that the deeper grain sizes of the old layers are smaller, while the new layers are larger. This is consistent with the higher energy flows in the meltwater that would exist closer to the glacier. Jeff. That's my sister Jeff's slide. Hold on.
Okay. Oh, hello there, children. My name is Professor Wigglesworth, and I'm here to tell you about aggregate properties, the physical, chemical, and general characteristics. Physical properties: absorption, porosity, surface, texture, strength and elasticity, which is an important one, density, aggregate voids, hardness, shape, coatings, and undesirable physical characteristics. Surface texture. It applies to cement bond. If it is smooth, the cement does not bond to it as well. If it's rough, then it bonds well, but it makes a less workable mixture. Grip. Okay, Next slide. Absorption, porosity, and permeability. Pore characteristics refer to the size, number, and interconnection of the pores. They basically affect the ability to resist the freeze-thaw cycle. Strength is the resistance to tensile and compressive forces. Elasticity is a material's ability to deform. It also helps resist the freeze-thaw cycle. We want both, of course, but in engineering, there is no free lunch. Density indicates the porosity in voids, which indicates freeze-thaw stuff. Hardness is the resistance to abrasion and degradation. We have several different shapes. Ideally, we would like crushed and rough aggregate because of its inherent increased friction and its better properties. Smooth and round aggregate makes the mix more workable, but it reduces the strength. Coatings. We want to resist or choose aggregate with...
Never mind, you can't read it anyway, James.
Yeah. Undesirable physical components. We don't want structurally weak particles such as clay, or flat or elongated particles, or those with organic material. Chemical properties. Some aggregates react to salt water and will expand and destroy it, as we see in this slide. General characteristics, compacted aggregates. Who really cares about these guys?
Alright, there are 5 requirements for hot mix asphalt. It needs to be strong, tough, and durable. It needs to be crushed easily, low porosity and low permeability, and the correct particle size and gradation for the type of pavement. For Portland cement, there are many more requirements because it has many different uses such as roads, bridges, buildings, and canoes. Factors to consider are the size and interconnection of voids, the texture of the particles, the gradation, the composition, the shape, and water absorption.
That is it.
Okay, now it's recording.
Hello, boys and girls. It's getting a little hot under these heat lamps. Oh, sorry about that. Well, I want to talk to you about some aggregates. The economics of aggregates. There's a market for them. There's a supply and a demand in customers. In order to have a demand, you must meet it with a supply. Future of aggregate industry. We have repairs to buildings and roads, new construction projects, and growing cities. Aggregates will solve these problems. The demand for gravel. There's always a demand. There's highway projects. 3 new proposed mining operations in Washington. Housing developments. Building blocks of nearly all construction is gravel. It's a billion-dollar industry. Whenever there's economic expansion, there is an upward demand for gravel. Local supply of gravel is endless. Puget Sound is naturally blessed, kind of like me. Particularly South Sound prehistoric deltas. DuPont Pit, the size of downtown Tacoma. This is huge. 387 acres plus a new 187 acres times 80 feet of depth. That's a lot of acres. Transportation for gravel. This supplies it to customers. Trucks. Huge trucks. Barges, as you can see in that picture. Right there. 186 trucks equals 1 barge. Gravel controversy. It destroys natural landscape, groundwater contamination, and possible noise pollution. Quarry opposition. Landowners, they do not want quarries in their backyards. They want them anywhere but their backyards. Local environmental groups are also against quarries. Problems with this. The demand doesn't change, but the supply decreases. It's an artificial decrease in supply because we cannot supply the customers because everything is held up in the courts. See the gavel right there. It's very difficult to mine new quarries. There's always a public outcry, and it gets stuck in the courts. To end this, boys and girls, what is the future of aggregates? It's here to stay. Everlasting industry, always a market, always a demand, always a supply in Western Washington. Thank you, boys and girls.
Hey, handsome!
Hey!
You want a match?